Hello and welcome back. In this episode we're going to take a look at creating a new web application. We're going to register that web application as a client inside IdentityServer. We're then going to sign in a test user into the web application via IdentityServer. We then get an access token and use that access token to send an authenticated request to our API project. So what we're going to do is right-click the IdentityServer solution, add a new project, select ASP.NET Core Web Application, give it a name of Web Application, and under Type, select Web App, and under Authentication, select No Authentication, because we'll be configuring that manually in just a moment. If we now hit Create, this will create our brand new ASP.NET Core Razor Pages web application. And we can see here we have our web application project. Now what we're going to want to do is install a couple of NuGet packages. So we can come into here, and the first package we're going to want is the identity model package. So we can select identity model and install that into our web application. And that comes with a number of useful extension methods that we can use to assist us with the authentication process. And the second package that we want is the ASP.NET Core Authentication OpenID Connect package. And this allows us to authenticate with an OpenID Connect provider, of which IdentityServer is one. So here we have our two packages installed into the project. And now what we're going to want to do is come into the startup class. And you can see at the moment we just add Razor Pages and we don't add any authentication yet. So that's what we're going to do now. We can say services.add authentication, and we should have an options callback function like so. Inside here we can say options.default scheme equals cookie authentication defaults.authentication scheme. We can then say options.default challenge scheme equals OpenID Connect defaults.authentication scheme. This configures the default fallback scheme to be the cookie authentication scheme. However, the default challenge scheme, which is what will actually sign the user in, will be this OpenID Connect authentication scheme. And that is what will redirect us to IdentityServer in order to sign in interactively. Next up, we're going to want to add cookie in order to add the cookie for the default fallback scheme above. And then in much the same fashion, we're going to add OpenID Connect to cover the OpenID Connect challenge scheme that we set above. Now this will give us an options callback like so, and inside here we can define our client details. So we can say options.authority equals the URL of our identity server. We're going to create this application with a client ID of web, a client secret of secret, a response type of code in order to use the authorization code with PKCE flow. We're then going to add an API scope into the list of predetermined scopes. This means that the access token we get back will be able to be used with the API that we created earlier, because you will recall that the API requires the API scope to be present in the access token in order to authenticate and authorize successfully. And then last but not least, we're going to save the tokens after authentication. So, with that defined here in the startup, we can scroll down to the configure method, and just above app.useAuthorizations, we can say app.useAuthentication, like so. Now this completes the authentication configuration for the web application, but the one last thing you might be wondering is, this authority URL here is hard-coded, which is all well and good running the application locally, but when we're running it in production, naturally the URL for the identity server won't be localhost. So what we can do is use the app settings and app settings.development to specify different values for the same property, depending on the environment. So if we come into app settings.development, we can create a new section at the bottom called authentication. Inside here we can create a property called OpenID Connect, and within there we can create a property called authority, like so. And we will give that a value of localhost port 5001, the URL of our identity server. In the production app settings, you could then create the exact same structure, but with the production URL of the identity server instead of localhost. What we can then do, come back into our startup, and we can say configuration, and then we can say authentication, :OpenID connect, :authority, like so. This tells the options to look inside the configuration for a key called authentication, which is this key just here. The colon then signifies nesting one level deeper to OpenID connect, which is this property one level deeper here. A colon again to move one level deeper, and we have our authority property, which is this value just here. So that completes the configuration options for OpenID Connect inside our web application. And we can now come into our Identity Server project, and we can register that web application as a client within our Identity Server database. So we can open up this program class, and you'll notice that we are getting the configuration DB context from the dependency injection container. And within this using statement, we can add our client using the configuration DB context. So what we're going to want to do is say configuration DB context.clients.add, and then we're going to add our client details in here like so. I'm going to import the missing references using the red light bulb like so. And I'll go over now this client configuration to explain it in a little bit more detail. The client ID is web because this is a web application, and that should match the client ID that we defined here in our startup for the web application. We then create a new client secret of just secret, which again matches the client secret in the web application. It goes without saying, if you're running this on a non-local environment, especially production, you'll want to give this a secure value rather than just secret. Next up, we specify the allowed grant type to be the authorization code grant type. That means that we can use the authorization code to interactively sign in the user and get an access token via the user signing in through IdentityServer. Next up, we have the redirect URI list, and you'll notice these are pointing to port 5005. So what we can do is come into our web application properties, open up launch settings, and you can see by default it gives us a port of 5001. But you may recall that is the port that's been allocated to the identity server. So we can change that to port 5005 for HTTPS and port 5004 for just HTTP. Coming back into our redirect URIs, you'll notice that we have this /signin-OIDC, and that is the default redirect URI that is provided out of the box by the OpenID Connect configuration from that OpenID Connect NuGet package that we installed at the beginning of this episode. Moving on, we have the post-logout redirect URIs. As the name suggests, these are the list of redirect URIs that the user can be redirected back to from IdentityServer after they have signed out of IdentityServer. You'll notice again port 5005, but this time the URL path is signout-callback-OIDC. And again, both of these values are defined as defaults within the OpenID Connect NuGet package. You can see then at the bottom we have a list of allowed scopes. Now, when we created our console application, we just had a allowed scope of API. But you can see here we have allowed scopes of OpenID and profile. That's because the console application was running non-interactively without an end user. It was just running as its own process in the background, whereas our web application is going to be running with an interactive end user. So the OpenID scope allows us to sign in using OpenID Connect, and the profile scope will allow us to get a list of the default profile claims such as name, family name, given name, username, etc. that's associated with the end user. So not only are we specifying the API scope as an allowed scope to access our API, we're also specifying the two interactive identity scopes of OpenID and Profile in order to sign the user in using OpenID Connect and then access their basic profile details. So this will add the client into our database. What we can do underneath is then just say configuration db context dot save changes like so. However, out of the box, IdentityServer doesn't register any of these OpenID or profile scopes. You'll recall if we look in our database and we take a look at API scopes, we have our API scope. But if we take a look at identity resources, you'll notice that this is empty. So what we can do back in our IdentityServer program class, just before we add this new client, we can come in here and we can say configuration db context dot identity resources, and we can add a new OpenID identity resource, converting it to an entity in order to store it in the database. So what this will do is this will new up a new OpenID identity resource, and if we control click into it, you can see here that it defines a few defaults, which means that we don't have to provide those defaults when we're newing up that identity resource. You can create your own identity resources, and you could simply say new identity resource and provide all of the required values within the identity resources constructor. Now this covers the OpenID identity resource. However, just beneath this, we're going to want to also add a new identity resource for the profile. So we can say new identity resources dot profile, and then we can say to entity to convert it into a database entity, and then that will add it into the identity resources table. If we control click into the profile, you can see here it configures this to be the profile scope like so, and you can see the display name is user profile, description of your user profile information, first name, last name, etc., which corresponds with the profile scope. You could also add other pre-built identity resources, such as email, in order to access the email, phone to access phone number, and address to access postal address. And those are all defined as defaults that you can simply add to your identity server by adding them as identity resources via new identity resources.openid.profile.email, etc. Or, as I mentioned, you can new up your own identity resources if you have custom bespoke requirements, and you can add those custom identity resources into the identity resources table in the database. What we can then do is configuration db context.save changes there, just before we then add the clients into the database. So if we now select our identity server from the run configurations, and if we now run the identity server, give it a few moments to build and run the application, we can see here it's adding that data into the database, and it's now opened up our identity server. If we come back into our IDE, and if we scroll down to the clients table, open up the clients table, you can see we have our console client, our Swagger client, and we now have a web client. If we take a look at our client grant types table, you can see that our console client is set up to use client credentials flow, and our web client is set up to use authorization code flow. If we take a look at client scopes, you can see that our console application is set to just use the API scope. However, our web application is set to use the API scope and the profile scope and the OpenID scope. Again, those bottom two being the interactive user-centric scopes. Next up, if we come down to identity resources, you can see that OpenID and profile have been added as identity resources inside the database. If you chose to register additional identity resources such as email, address, phone, etc., then those will appear in this identity resources table. So, with this inside the identity server like so, having been created successfully, we can get rid of that like so, and close that program class down. We can also close the database on the right hand side as we're done with that for now. If we scroll back down to our web application, back in our startup, we can verify that this all looks good to go, and we can then come into the top right, select web application, and we can then run our web application. This will take a few moments just to build and run the web application, and you can see here, welcome to our new ASP.NET Core web application. So, at the moment, this is completely unauthenticated. Users can navigate freely around the website without any sort of authentication or authorization prompts. Now, what we can do is we can create a new page to go off and get data from our API. So what we're going to want to do is come back into our web application project. If we close the startup for now, inside our pages folder, you can see we have a page for error, a page for index, and a page for privacy. We're going to want to right click, add, and we're going to select a page from the options just here, and we're going to give this page a name of API, like so. What we can do is we can leave the page annotation as is, and the model we're simply going to update to API model, like so. And inside our code behind, we could simply name the class API model. And this is then consistent with all of the other pages and the page models that are already configured in this project. So, closing the code behind for now, which we will come back to a little bit later on, we can look and see in our API view code, it's given it a layout of null, and it's created this sort of base HTML structure. However, in our view start file, we define a default layout to be used as the main layout when rendering our web pages. So what we can do, we can get rid of that layout equals null, and that means that we will then use the shared layout that's defined in this layout partial here. Now this contains things such as the nav bar, also a footer at the bottom, and we can see this render body method call is where it will actually render each of the pages. So if we take the index page for example, you can see this div here will be displayed inside this main block here, because render body will essentially render this div here into that location in the web page. So we can see here at the top we have a view data title, and we can see in the index we're setting that to home page. So what we can do is we can come into our API and we can say view data, and we can say title, and we can call that API. Feel free to give it any other name that you deem appropriate. What we can also then do is remove this default HTML that it creates for us, and if we come to our index page, we can see that we just have a basic div layout like so. So what we can do is we can come back into our API view, and we can simply say a div like so, and I'll simply give it some text of just API inside a paragraph tag like so. So with that like so, if we rerun our web application, give it a few moments and it should reopen like this, and with a bit of luck, if we go to /API in the URL, we can see here that we have our API page with a title up here of API and that paragraph text of API like so. Now this is all well and good, but we want to require the user to have to sign in order to access this page, because we're going to want this page to go off and use an access token to get data from the API. So what we can do, if we come back into our IDE, and if we scroll down and go into the code behind the page model for our view, and we can annotate the class with an authorize attribute. Now what will happen, if we stop and rerun the web application, give it a moment to build and spin back up. If we now once again go to /API in the address bar, You can see it takes a moment to load, and it will redirect us to our identity server. Now you'll recall that we specified a username of test@example.com, and this is a test user that we created in ASP.NET Identity, and we gave it a password of pass123 with a $sign. If we now click on login, we can ignore the save password prompt there like so, and we are now redirected back to our web application. This time though, we are authenticated. So what we can do, if we come back into our identity server, we can then, inside this onGet method, we can pull out the access token from the authorization response, and we can use that to send a request to our API. So what we're going to want to do is we're going to want to say var access token equals HTTP context dot get token async, and the token that we're going to want is the access token. Now what we're going to do is await that, and you'll notice we get a little red squiggle here because our method is currently synchronous. So what we can do is we can make method onGet async task, and we can simply name it onGet async, just a convention there to specify explicitly that the method is asynchronous. What we can then do is we can get ourselves an HTTP client, and we can use that access token in the HTTP client to make an HTTP request to our API. So what we're going to want to do is come back into our startup, and underneath our add authentication, we're going to want to say services.add HTTP client, like so. And this will add the HTTP client factory into our dependency injection container. So what we can do now, back in this code behind, we can say private HTTP client called HTTP client, and we can then use the IntelliSense to initialize property from constructor. However, instead of injecting an HTTP client directly into the constructor, we're going to want the HTTP client factory, like so. And what we can then do is HTTP client factory dot create client. And this will create an HTTP client that we can then use in our onGet async method. So what we can then do is we can say HTTP client dot set bearer token using the identity model package that we installed earlier, and we can then pass in the access token. Now what we can do is we can create a public property which is of type string, and we can say weather forecast, and we can say get and set. And what we can then do is we can say weather forecast equals HTTP client dot get string async, and it's going to be HTTPS localhost port 5003, which is the address of our API, and the controller is /weather forecast, like so. And all we can then do is simply pop in await at the beginning of that, so we await the asynchronous method. And what this will do is it will send an HTTP request to localhost port 5003 /weather forecast, which if we scroll up to our API project, inside controllers, we have our weather forecast controller. So it uses the weather forecast endpoint, which we can see just there, like so. And it will then convert that response into a string, and it will set that string as this weather forecast property. What we can then do inside our API here is we can get rid of this div and p for now, and we can say pre and then code, and we can say at model dot weather forecast, and this will essentially output that weather forecast string into a nicely pre-formatted code block on our API page. So if we close that weather forecast controller, and if we come back down to our API, essentially inside the view here we're setting a title of API, and we're then displaying the weather forecast output from the API in a pre-formatted code block. Inside the code behind page model for the view, we're injecting the HTTP client factory that we added in the startup class. We're then using that HTTP client factory to create a client. We are then getting the access token from the HTTP context using http context.getTokenAsync, and we're getting the access token. We're then setting that access token as the bearer token within the HTTP client, and we're then setting the weather forecast to be a stream response that we get back from the weather forecast endpoint. So what I'm going to do is come down to our API run configuration and run that API. Give that a few moments to build and spin up our API. We can see here we have our Swagger page. If I then close that, and if I close that because we're now going to want to rerun our web application project. So if we stop and rerun that web application like so, give it a few moments to build and spin up, and here we have our web application. If I then go to /API in the address bar, we can see we are redirected to IdentityServer, where we can enter our username of test@example.com, and we can then enter our password. That's pass123 with a $sign if you followed along and created the default test user within our ASP.NET identity database. If we then hit login, we can close that prompt, and you can see here we have our weather forecast data from our weather forecast API. So essentially, this has shown you how you can create a new web application, how within the startup you can add authentication and configure the OpenID Connect options. We've then added our HTTP client into the dependency injection container, which means that we have access to the HTTP client factory. We've specified the authorized attribute on the API page, which means that the user must be authenticated and authorized in order to access this page. We've then pulled the access token out of the HTTP context. We've set that access token as the bearer token for the HTTP client, and we've then used that authenticated HTTP client to get the string response from the weather forecast endpoint of our API. And then last but not least, we added the web application client as a client inside our IdentityServer database. So that's essentially showing you how you can create an interactive web application with an end user able to sign into the application through IdentityServer, and the web application to then use an access token to send an authenticated request to an API endpoint. I hope you found this episode useful. Thank you very much for watching, and I'll see you next time.